And I want you to focus on number C, G, and H. C, G, and H. And the reason I want you to focus on those is, what do they all have in common? They got radicals. And radicals and calculus don't mix. So you need to get used to, whenever you see a radical, rewrite it. All right? So write those three down. And then we'll continue. I'm going to write them up here so I can copy and paste them, if it'll let me. Let's see, log base 5, square root of 8, log base A, cube root of 1 squared, log base B, nth root of x cubed, y cubed, over z to the n. Probably not going to copy in there. Huh? Y to the fifth. I can't ask for too much, can I? Oh, I can't do anything. I'm glad you were able to make it today. All right. So, log base 5 of 8 to the what? 1/2 power. And what can we do with that 1/2? Bring it out front. 1/2 log base 5 of 8. Change base formula. 1/2 log of 8 over the log of 5. Now, I don't know if they have shown you the change base formula, so either one of these answers could be correct depending on what part of the book we're in. This is written in the expanded form, and this is change base. So I don't think change base is until the next section. So that's probably going to be what they have in the example. So look in the example, what page were we on? 364. Somebody look on 364, number C, and see what the answer is. See if they wrote it in change base. They probably left it like this. Anybody got a book? We'll look in that. All right. Now this one. Log base A, cube root of m squared. That can be written as log base A of m to the what?
2/3.
2/3. And then that's 2/3 log base A of m. That would be the answer probably in the book of the example. But if you did the change base, it would be 2/3 brackets log of m over log of A. And log being base 10. So that would be your change base answer. So this would probably be your answer in the example. Now you try C. A, right here. B, right here. And you try C. Just looking, what did they do on the, which one did we do? C? Okay. They got 1/2 log base 5 of 8, so they did not do the change base formula there, but I put a star beside that. What's the other one we did? G, they did that. They didn't put the change base formula. The reason they didn't do the change base formula is we hadn't got there yet, but I've already shown it to you, so it's not that big a deal. So let's see if I can copy. I doubt I can copy that over, so I'm just going to go to the next page and hit paste again and erase these two. Now the key to doing these types of problems is knowing what to do first. And that's why I'm trying to show you the radical, you rewrite it first. So this would be log base b parentheses x cubed y to the 5th z to the m raised to the what? 1 over n. Now, a lot of you say, well, why can't we distribute the 1 over n, use the power rule? That would be okay. But, is there an easier way to get rid of that 1 over n? Yes. Bring it what? Bring it out front, and that way you don't have to worry about it. So 1 over n times log base b of x cubed y to the 5th over z to the n. Now, of course, if you wanted to rewrite that with the change base formula, that's the answer. You would say 1 over n brackets log base 10 of x cubed y to the 5th over z to the m over log base 10 of b. Of course, you would have to know what all those variables are in order to do it. So this is this right here, from here to here, is very important in calculus. Whenever you see this guy, you know you've got to rewrite it. Those are some examples. You could rewrite this one the log base 9 of 15 minus the log base 9 of what? 7.
So on that last one, the reason I took it out even further and did like the log base b of x plus log base b
Yeah,
of
we
log.
could have. Yes, I don't know if they want, let's look and see if they want to take it out that far. Because that would be a long, drawn out, hold on. Let me see if they want to take it out that far. Yep, they did. So we'll go ahead and take it on out. I don't know if they wanted to or not.
So what would you want to test or?
Well, I'm gonna pick the problems off of the homework, so they're gonna wanna keep going. So, let's finish this right here. So, this would be 1 over n, and then that would be the log base b of x cubed plus what? Log of y to the 5th minus log of z to the n. So, let me take that.
Did you bring those exponents over?
Yeah, bring them over. So let me go ahead and do that. Let me just move the whole thing over. Thanks a lot. I'll just copy it over. 1 over n. 1 over n. Log base b of what? X,
X cubed.
y to the 5th
Yeah.
over z to the m.
Yeah.
Okay, remember, this is multiplied by the whole thing, so you might as well go ahead and put it in brackets because you're going to work with what's in brackets. So pull this out, 1 over n, brackets, log base b of x to the 3rd plus log base b of y to the 5th minus log base b of z to the m, close brackets. And now you bring each one of these out just in case you wanted to distribute that 1 over n. So that'd be 1 over n, brackets, 3 log base b of x plus 5 log base b of y minus m log base b of z, close brackets. And at this point, you may or may not distribute the 1n, so I'm going to put or, and then I'm going to put 3 over n log base b of x plus 5 over n log base b of y minus m over n log base b of z. So you've got two possible answers. And we'll look and see which one they said. Let me look right quick and see which one. Did they distribute it? Yeah. They distributed the 1 over n. So in this case, this would be your answer right here. Let's say that on the test you didn't distribute that 1 over n all the way through, and the course compass marked it all the way wrong. I'd probably give you 75% of the grade, 75 out of 100, just because you didn't distribute that. I wouldn't mark it all the way, but that's a challenge that you would have to see me about. Okay? Thanks for asking that. I didn't think to take it on out. All right, let's do another one. Let's find one out of the homework or see what they did next. Is that one? Let's see. Okay, now this is going the opposite way. This is going backwards. So see if you can work those three, and we'll write them on a white page and do each one of them separately. This is, we're condensing. We're taking an expanded version and taking it down and condensing, simplifying. Where above, we were taking a condensed version and expanding it. a couple of minutes to write that down. Just been holding my mouth right. All right, first one, we all have the same basis. So that means we can rewrite this as log base 3 of whatever, whatever, whatever. So I'm going to put it in parentheses, and that would be x plus 2 times x over what? 2. And you could distribute that x, and that would be log base 3 of x squared plus 2x over 2.
You wouldn't have to simplify that.
Well, there's really no way to simplify it unless you know what x is.
What do you do?
What 2's?
Yeah, you
You can't cancel unless you do this. If you put the x squared over 2, you can do this. Log base 3 of x squared over 2 plus 2x over 2. And then you can do that, and that would give you log base 3 of x squared over 2 plus x. But you can't just cancel the 2's right there because of that plus symbol. That plus symbol prohibits you to do that because these two are joined. But you could do that and break it up with this.
Can you really leave it undistributed after you get here?
Yeah, but chances are they may mark this one wrong. I don't know. It all depends on the homework. But on a test, I would take either of these answers. Okay, that's that one. Okay, now the first thing you want to do here is get rid of the coefficients. So how do you get rid of this 2 and this 3? Using the exponential rule or the power rule. And now you have both log base A, so therefore you can put the quotient rule in effect. Of what?
N squared divided by n to the
Good.
third power.
And then the last one. Well, you know the coefficients are in a way because you don't have the same basis. So you're going to have to move the coefficients out of the way. That 1/2 is going to have to go somewhere. So log base B of m to the 1/2 plus log base B of 2n to the 3/2 minus log base B of m squared n. So now you have all log base b's. You know, that's the product rule and the quotient rule. So log base b, BA parentheses, of what? M to the 1/2 times 2n to the 3/2 over m squared what? N. Now, based on how far they want you to go, you could actually go further. Because this is the square root, you could actually subtract exponents here. The 2 to the 3/2 could be by itself, and then you'd have n to the 3/2 and 2/2 down here. So I'm going to go ahead and circle this as an answer, but I'm going to take it to the next page to see what they do. We're going to circle that as a possible answer. And I'm going to copy it. I can't expect too much.
You can't pull it down to the center. Well, you can't pull it down to the center box.
And that's pushing it. So we'll copy that over to the next page. And then I'll just erase the top. And we'll move that up. And I'm going to say this is log base B of, big set of parentheses, so I'm going to write a little bit bigger. That'd be m to the 1/2 divided by, or over, m squared n to the first, and that's going to be 2 to the 3 halves, and n to the 3 halves. Now, I want to keep my variables what? I want to keep them positive, right? So I'm going to take this down here, and that's going to become a negative 1/2. I'm going to take this one up here, and that's going to be 2 halves. Why is it 2 halves? Because it has an exponent of 1, and I'm changing it to common denominator. So log base b of m, or m's going to come down, so that's going to be 2 to the 3 halves, n to the 3 halves minus 2 halves, over m to the 2 minus 1/2. And you can change this to 4 halves if you want to. So another possible answer that they may have is log base b of 2 to the 3 halves times n to the what? 1/2 over m to the 3 halves. And the only other possible answer they could have is put all that in terms of radicals. And that would be exponent over index. That would be 2 square root, or let's see, that would be exponent over index. That would be the square root of 2 to the 3rd, which is the square root of 8. So log base b of the square root of 8 n, right, over the square root, and that'd be over m to the 3rd. So that's another possible answer. Huh? Let's see what it does. Where is it? Oh, C's on the next page. Is that C?
Yeah.
So that is the last one. Log base b of 8n, square root of 8n over m to the 3rd. Log base b square root of 8n over m to the 3rd. All this is manipulation. That's all it is. Think of it like this. Beethoven's Fifth, did I give you all this scenario? All right, you're going to play the piano. They give you Beethoven's Fifth, and they tell you in December you got to be able to play at the recital. He or she has shown you the notes. I've shown you how to expand and how to expand and condense. Now you've got to what? Practice it. And the only way to get good at this stuff is the same way that if you were going to play Beethoven's Fifth, you get it practicing 3 minutes a week, or do you get it practicing 3 hours a week? 3 hours a week. You're not going to get this. You're not going to get logarithms unless you practice them over and over and over and over. So think of this as practicing Beethoven's Fifth. And we've only got to add 2 more things, and that is the change-based formula, which I already showed you, and how to solve equations. We haven't shown you how to should do that. Okay? Right now, we're just getting you used to the properties.
Maybe having that, I have a question I'm trying to figure out the best way to answer it. I didn't get everything. I understand the very bottom of the log B, I understand that you want to combine the ends to get them on one fund. I know that n 1/2 and n squared, so you said we got 4 over 2.
4 over 2. This is m squared. You might as well say 2 over 1, right? All right? You can't subtract these two because they don't have what? like denominators. So I've got m to the 2 over 1. What did I have, minus or plus? I've got minus, what, 1/2? All right, I can't do this because I don't have a common denominator.
Right?
So I change common denominator from 1 to 2. 1 will go into 2, 2 times. 2 times 2 is 4.
Oh, I see. Maybe that's reasonable.
That's all right. Okay. Let's move on. I want to get y'all to not fractions. I want to get y'all to solving equations today. I'm going to do some more of these. There's a change base formula right there. So if you wasn't here the other day and you didn't watch the video, log base A of x. In other words, there's only 2 logs. Log base 10 and log base what? E. Log base E is natural log. If you don't have those 2 bases, then you're going to have to use this. So, give you an example. Why you got it. Why you write log base 2 of 4 is equal to log of 4 over log of 2 or natural log of 4 over natural log of 2. Because this is log base 10 and this is log base E. I don't use natural logs that much, so I don't do natural logs, I do LOG. And that's an example of this. The only logs that you can do on your calculator are log base 10, which is LOG. If there's nothing beside the LOG, it's usually assumed to be a 10. And log base E, which is equal to natural log. Those are the only 2 that your calculator can do. If your log does not look like these 2 right here, or these 2, then you have to use this. Now, I'm not going to spend a lot of time on this, because on a scale from 1 to 10, 10 being difficult, this is about a 1. It's just like trying to find pi on your calculator. I mean, it's not very difficult. We'll do a couple of problems, and you'll see how easy it is. Just like this one. It ain't very difficult. They're probably not going to give you too many examples. I thought they'd give you one with at least numbers in it. Oh, they're showing you the proof there, probably. Let's find one with numbers. There's one. Log base 5 is 17. Log base 5 is 17. That's equal to log 17 over what? Now somebody give me the log of 17 on your calculator. Yeah, tell me what it is. Log of 17.
1.2304.
That's good. Over log of 5. What's log of 5?
0.6989.
Okay. Now, do those and tell me what you get.
1.78.
Dot, dot, dot. Now, if you can't do that, then we need to have a talk. All right? Because you're in college algebra, you should be able to do this. Now, when will you use this? You're going to use it when we're doing equations. Okay? So, on the test, are you going to have a lot of these? No, but you will have them in the problems with the equations. As far as by themselves, you might have 1 or 2, and that's just to give you some more points, besides the Hubert questions to give you a couple more points. So you might have 1 or 2 of these on the test. So just check back, make sure we got it right. Which if we didn't, I'm going to quit. What did we get? Did we get 1.76? Okay.
Well, Mr. Pruitt led me astray, but anyway,
That's okay. That's close enough for government work. And this one would be the log of .1 over the log of what? So I'm not gonna spend a lot of time on that. Let's go through a couple of exercises that, or let's go through, I don't want to do exercises because I don't have the answers. So let's go through a couple of problems in your homework that I would pick for the test for 5.3. Forget that. These are all definition of logarithm. Which y'all should be able to do. We'll do this one. Definition of a logarithm. Pull out your definition of a logarithm. Definition of a logarithm is a to the y is equal to x. I gave it to you the other day. I don't think I still have it on here because I probably started the computer over. Let me see if I still got it. Insert media. Nope. Nope. I'll pull it back up for you. I can't pull it out of the book, so I'll just pull it out from the internet. I spelled definition. Is there two I's?
I think there's two
That's right.
That's right.
That's right.
I can't spell very good. That ain't what I want. Oh.
Right there. Go down.
Forget it. Go to images. They'll show. There we go. There's the one I pulled up right there. Well, what happened to it? Good golly molly. View image. Okay, forget it. There it is. Y is equal to log base b of x, b to the y. I use a. Y is equal to log base a of x. A to the y is equal to x. So that's what you need to use for this problem. And this problem says that. So y is on the right hand side. So this is what I would do. Y is equal to log base a of what? X. And we know that this yields a to the y is equal to x, correct? So what's my a? X. What's my y? And what's my x? Now, what did we just talk about exponential exponent? I mean, a rational exponent. Exponent over what? Index. So that's the fourth root. And you could, if you wanted to, multiply by the, no, don't do that. That's the fourth root of x to the third power, right? The fourth root of x to the third power is equal to 125. How do you undo a fourth root? You raise it to the what? You raise it to the fourth power. And then x is equal to the cube root of 125 to the fourth power. Well, you don't need your calculator yet. X is equal to the cube root of 125 to the third power times 125 to the what? First power. And what's the cube root of 125 to the third power? 125 times the square root of 125. So I don't know if they're going to come out with all that or not. I don't know if they want to go that far or not. Let's punch it in to see what they get. Let's see, it says type exact answer. So they're wanting, I would say 125 times the square root of 125 times the square root, unless they don't want to go that far. Is it the square root? No, it's the third root. Sorry. Third root of 125. Wait a minute, what's the cube root of 125? 5? So that'd be 5 times 125, so 625. Sorry. And that's how you do that. I forgot this is a cube root. Right here, that's a cube root. And the cube root of 125 is 5. And 5 times 125 is dang old 625. But y'all knew that. Y'all just didn't correct me. Right?
That's crazy. I just thought it was crazy that you could add it like this.
There. Hopefully y'all remember your radical rules. I feel some Patrick Starfish vibes. Patrick, the orb of confusion is off. I really don't like Patrick. My favorite is Plankton and Squidward. Huh? Yeah. I think I'll go home and throw up. And these are all definitions, and I'm not going to do definitions. I mean, I'm not going to do them right now because we've already done them. I want to get to the expansion if we ever get to them. Here we go. Here's the expansion. Okay, there's one. Expand that one. Log base 9 of 9 times the square root of 11 over 13m. These are the ones that I would hit similar exercise over and over and over. Can you hit similar exercise if you get it right? I think you can, can't you? Or go to study plan and do them over and over.
The problem is, some of the similar exercises are the same problem.
Well, they usually regenerate and change one thing. I mean, they usually do. It's Bush's fault. It was his fault. He paid the people to do it.
I had to laugh when the test when it said, when is the last day of school? You say 9/11/2001.
Yeah, somebody picked it.
They did. It had to be done.
Listen, I got some people that, I got students that we just, they can't spell mom backwards. Somebody had to think about that, didn't you? All right. Mom. Is that like race car backwards? All right. Log base 9. Okay, what's happening here? This is division.
And multiple.
You got all kinds of stuff going on here. So let's go ahead and break this up into log base 9 of 9 plus log base 9 of square root of 11 minus what?
Log base 9, 13 plus log base 9, m.
What's this?
What?
Good job. 1 plus 1/2 log base 9 of 11 minus log base 9 of 13 plus log base 9 of n. That's probably going to be your answer. I'm not typing all that in. I'm just going to type in 3. Get the wrong answer. Okay, go away. My mouse is not working. Go away. Go away.
That
1 plus 1/2. Look at there. We got it right, y'all. We feel good about ourselves. So we don't have to be an Oompa Loompa and put too much makeup on our face. Have an orange face and a white neck. All right. Try that one. Y'all ever seen an Oompa Loompa? An Oompa Loompa, orange face and a white neck.
A lot of them go to prom.
Yeah, a girl with an orange face and a white neck.
The old one or the new?
No, I'm talking about people.
Yes. In the movie.
No.
Charlie and the Chocolate Factory. They're two completely different people.
I'm going to have to show you what an Oompa Loompa is.
I know what a Oompa Loompa is. It depends on if you watch the old one or the new one. Yeah.
So it doesn't want us to distribute the 1/2 on this one.
See, that's
Wait a
the
minute,
old
I got to show what Oompa Loompa is.
one. That is the old one.
He's saying that people look like.
There's an Oompa Loompa. Well, but she disappeared too. I don't know what happened. That's an Oompa Loompa. Orange face and a white neck. Ooh. Woo. Phew. Can you imagine? Trying to find some more. They have them all listed on here. There's some guys. Ooh. I don't know what that is. We're talking about Oompa Loompa, self-confidence. Women don't have self-confidence. They do this. You don't listen to anything I say, do you? I said, now we feel good about ourselves, so we don't have to put on too much makeup. Yeah, exactly. All right. I don't forgot what page I was on. I guess everybody'd be happy if I just do like Muhammad and just teach 300 pages and everybody'd be happy. All right. Yeah. Teach 3-4 sections in 20 minutes. All right. Log base M. So log base M. What are we going to do first? We're going to rewrite it as 7r to the 5th over z to the 7th raised to the what? 1/2. Bring that 1/2 out. 1/2 log base M of 7r to the 5th over z to the 7th. Now what can we do with that? Remember the 1/2 is out front. So that's going to be 1/2 log base M of 7 plus log base M r to the 5th minus log base M of z to the 7th. And then the 5 can come out front. So that's 1/2 log base m to the 7 plus 5 log base m to the r minus 7 log base m to the z.
Yeah.
And now we can distribute if it wants us to. Okay, so it'd be one of these. It ain't gonna be this one, is it? It's gonna be one of these.
Would it want us to distribute and then put it back into?
Okay, it looks like it. There it is. 5 log minus what? 7? Looks like this one.
If you went further,
The only thing you could do is distribute the 1/2.
So the book wants us to distribute it and the homework doesn't?
Well, it depend. I think they would just depend on the length of the problem. So this one's condensing. That one's a little bit too easy. Try this one. Four log base b of x minus 6 log base b of y to the 5th. So that could be written as log base b of x to the 4th minus log base b of y to the what? 30th. And that can be written as log base b of x to the 4th over y to the 30th. And see, this one they don't want you to, they want you to write the answer out. So this would be log base b of, I'm going to put parentheses, and then x to the 4th over y to the 30th, and then close parentheses. Next one. All right, try that one. Negative 2/3 log base 6 of 2m squared plus 1/2 log base 6 of 4m squared. The negative 2/3 comes out. That's going to be log base 6 of 2m squared raised to the negative 2/3 plus log base 6 of 4m squared raised to the 1/2. And that's going to be log base 6 of 2m squared raised to the negative 2/3 times 4m squared raised to the 1/2. Now we can actually take that and probably do a little bit more to it. Let's go with, let's go to this page and over here, I'm going to erase all this and move this up. And that's going to be log base 6 of 2 to the negative 2/3 m to the negative 4/3, 4 to the 1/2, m to the 2/2. And it looks like we can maybe put these two together and these two together. I don't know if it's going to help us or not. But log base 6 of 2 to the negative 2/3, 4 to the 1/2, m to the negative 4/3 times m to the 2/2. This can be written as 2 to the 2nd power, which can be written as, and we could add those two if you wanted to do it that way. I don't care how you do it. There's several different ways you can do this. So I'm gonna write log base 6 of 2 to the negative 2 halves, 2 to the what? 2 halves, because what is 4? 2 to the second power raised to the 1/2, and what's 1/2 times 2? Huh? 2 over 2, right? Okay, so that's how I got that. And negative 2 plus 2 is what? Is 2 to the 1, which is what? 2. So log base 6 of 2, and then we got this guy, get a common denominator of 6 maybe, or we can change this. This is 1, change it to 3/3. So that's going to be negative 1/3 m to the negative 1/3, which what can we do with that m to the negative 1/3? Bring it what? Down, and that'd be m to the 3rd. So it looks like our final answer is going to be log base 6 of 2 over m to the 3rd.
Now, before you go in there, let me ask you a question. You have log base 6, 2 raised to the negative 2/3, and when you bring it down, it's 2 raised to the negative 2 over 2.
All right, where?
Right there in the second line, you got going. See how it's negative 2 over 3? And then when you go down, it's negative 2 over 2.
I guess I just wrote it down wrong. Sorry. Okay, I'll fix it. So that would be 2/3. So that takes care of that. That'd be we bring it down. Well, we could still make this right here. This is 1, right? Didn't we make this 1 right here? 1/2 times 2. So we could change this to 3/3. And 3/3, negative 2 plus 3 is 1/3. So that'd be 1/3. So that's the cube root of 2. There. Let's see what the answer is. Let's see what I wrote down first. Where's mine? Cube root of 2 over m to the 3rd. Cube root of 2 over m to the 3rd.
Here's the A.
Right here.
Yeah.
I thought I had cube root of 2.
Well, you did that after I said something.
Yeah. So that's, I want cube root of 2. I ain't got cube root of 2.
The reason why you know that entry is doing this is because when you write it down, you switch to it.
Oh, I didn't. I switched. I did something.
Yeah.
Oh, there should be what?
Well, you're pairing up like terms and all, I get
Yeah.
that, but you can't change what the exponent, because it's.
Check it. Right here.
You just have to do it.
I changed it. You told me to change that to negative 2/3.
I know, I'm saying what she's saying. It's different.
What?
Yeah, just start it. Just see what it says and then we'll go with that. Go with yours.
Well, I don't see my answer. I've got the cube root of 2 over m to the 3rd. And I don't see the cube root of 2 over m to the 3rd. So I'm missing something, so I need to do it over. If I'm missing something, let me do it over. Where is the problem? This is it. This is it. 4m squared. That's it. Make sure I've got everything on there. Is that it? Okay, log base 6, 2m squared raised to the negative 2/3 plus b, well, since we're putting it in 1, it'd be times log base 6 of 4m squared raised to the 1/2, right? And that's going to be log base 6 of 2 to the negative 2/3, m to the negative 4/3. That doesn't need to be here, sorry. Okay. 4 to the 1/2, m to the 2/2. Everybody with me? Okay, now I'm going to combine log base 6 of 2 to the negative 2/3, 4 to the 1/2. Put those two together. And then m to the negative 4/3 times m to the 2/2. Put those two together. Now, I can change, let's see, I can't change these, I can change this to 2 to the, I can do that. So that'd be 2 to the 2/2. Everybody with me? So times 2 to the 2/2. And if you don't believe me, what's the square root of 4? 2 to the first power. So there's that. And then, since this is 1, I can change this, not 2/2, but I can change it to what? 3/3. Get a common denominator. All right? Over here, I really can't do anything. I can change this to 3/3. And now I got log base 6 of 2 to the 1/3. I think that's where I messed up. Times m to the what? Negative 1/3. There's where I messed up. And that one can come down, and that's m to the 1/3, and that's the square root, the cube root of both of them. That's where I messed up. Log base 6 of the cube root of 2/n. That's your answer. So, which answer is that? Square root of, cube root of 2/m. C. And those change base, y'all know how to do the change base right there. Log base 8/70. Log base 8 is 70. I'm not going to ask you, that's log of 70 over log of 8. And that takes care of that section. Now, I want to talk about solving equations. And let me get out of this, close, and go back to x 5-3, it should be 5-4. All right, let's take this example right here. I'm going to write it down and get it on the page. Log base 3 of x plus 6 minus log base 3 of x plus 2 equals log base 3 of x. Okay? All right. Now here's where your properties are going to come into play. First thing you realize is that all of these are log base what? So now we're going to rewrite the left side as log base 3 of x plus 6 over what? X plus 2 is equal to log base 3 of x. And this is a real simple equation because if you have the log base 3 of this is equal to the log base 3 of this, what can you do with these two guys? Look what they do. Right here. If you have the log of this equal the log of this and the bases are the same, what can you do with them? They set equal what? You can set them equal to each other. So these two guys since they're in the same space. Now, what if this was log base 4? Then you'd have a totally different problem. But since they're in the same spot, it's just like, remember that problem we did? And I had 2 to the x is equal to 2 to the 4th. And I told you that these two are what? The two exponents, since the bases are the same, the two exponents are what? Equal to each other. We did this problem the other day. Y'all remember doing that? Same thing. If you have the same base, and you have two terms right here, then you can set these two terms what? Equal to each other. So x plus 6 over x plus 2 is equal to x. Now, finish it. Use your algebra. Always get rid of the fraction first. Multiply through by the common denominator. How do you get rid of a fraction? Common denominator. So I'm going to multiply both sides by what? X plus 2 over 1. And what happens to the x plus 2? And you have x plus 6 is equal to x times x plus 2. And what do you do over there? X squared plus 2x is equal to x plus 6. Now what? Quit. It gives you like terms over. Do you want to make the x squared negative or positive? Positive. You want to keep it positive, so you leave it. If it ain't broke, don't fix it. So you leave that x squared alone, unless you just like punishment. So 0 is equal to x squared plus 2x minus x. And then minus what? Reverse FOIL. Be careful. Be careful because 1 and 5 can get you on this one, or 2 and 3. So, I mean, when you got a 6 there. But luckily, this is 1, so you know it's 2 and 3. 2 and 3, this means positive, so that means the 3 is what? This means what? Unlike. So unlike from positive is negative. So your answers are +2 or -3. I've forgotten what the question was, so we got to go back to the question. And it says log of blah, 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 blah equals the log of blah. Can you take the cube root of a negative? Can you take the log of a negative?
No.
So the answer is probably 2. We should say it in there right there. Solution to the Now take a look at this one. This one don't have a log on the other side. So this one is log of 3x plus 2 plus the log of x minus 1 equals 1. So use your property here and then see if you know what to do next. What's the log? It doesn't have anything
Base
here.
10.
Base 10, good job. 3x plus 2 times x minus 1 is equal to 1. And what are you going to do here? Huh? Dang old FOIL. Pronounce it however you like. FOIL. I guess I better take the roll. Glad we had people come back. Ain't seen in a while. Missing people. What do you call it? Missing in action. Huh?
Needed.
Yep. Faculty, students. That's on 10. Set attendance. Miss Anderson is here. Barron was here. Borth. Crane. Crenshaw. No Crenshaw. DeVore. Evans was here. Fisher.
Here.
Hall. Keller was here. Lou is here. No, Lou's not here. God, he never misses. I must work him too hard. Moore. Nix.
Here.
Pace was here. Oh yeah, there he is. He decided to show up today. Page is finally back with us. Pahela is here. Pruitt is here. Sab is here. Sloger, glad to have you back, Miss Sloger. And Walton, as in Mountain, not here. Woods,
He's
huh?
He's not here.
He's not here. Okay, this problem. I mean, I got 10 minutes left, haven't I? I'm gonna be like Dr. Gabati, I'm gonna keep y'all here till the last second. How does he do it? You need to sit down. I need to do the monotone just like him too.
We'll keep doing it for next.
Huh?
We'll keep doing it for next.
To the last second. Yeah, till the next teacher comes in. All right, so we got, let's go ahead and do this, and that's going to give us log. Log of 3x squared, that would be minus 3x plus 2x is negative x. Somebody help me out. Minus 2 is equal to 1. Now what do we have? We have the definition of a what? Logarithm. Good job. So y is equal to log base a of x. And what is that equal to? A to the y is equal to what? X. So what's my A? 10, Hubert. What's my y? 1 is equal to 3x squared minus x minus 2. So let's take that over. And I'm just going 3x squared minus x minus 2 is equal to 10. Bring the 10 over. 3x squared minus x. What's negative 2 minus 10?
Negative 12.
And then break it up. Of course, I would do complete and squared, but you know, people have a fit if I did that. So 1x, 3x. And let's try, we need a 3 and a 4, so I'm going to go with, well, that can't be 3 and 4. 3 and 4 won't give you a 1. 2 and 6. No. Might have to use complete and square. I want to use complete and square anyway. I don't like to use reverse FOIA. It takes too long. So, 3x squared minus x plus blank is equal to 12 plus blank. Factor out of 3, you get x squared minus 1/3 x plus blank is equal to 12 plus 3 times blank. Half of 1/3 multiplied with 1/6. 1/6 is 1/36. Somebody check my math there. 1/36. And that's going to be 3 times x minus 1/6, quantity squared, is going to be equal to, and we can take that out and take that out of a 12, right? 3 over 136, 12 times, right? And this will be 144 over 12. 144 plus 1 is 145. 145 over 12. And then divide by 3, multiply by 1/3, that's going to be x minus 1/6, quantity squared, is equal to 145 over 36. Square root of both sides, that's going to be x minus 1/6 is equal to, the square root of 145 is going to be 12.1 over 6, and that's going to be x is equal to 12.1 plus or minus plus 6 plus 1 over 6. I know we got 5 minutes left. 12.1 plus 1 is 13.1 divided by 6. 13.1 divided by 6 And negative 12.1 plus 1 is negative 11.1 over 6. And what do we not want if we're taking the log? I don't know, so I don't know, I think that one's going to be out. What is 13.1 over 6? Dang old 2.2. I don't know what the answer is. We'll look.
Yeah, it's here.
Where's our answer? Is that the one we're doing? Somebody do 1 plus the square root of 145 over 6. What does that give you? Somebody do that. One plus the square root of 145 over 6
Three.
comes out to be 3.
3.0069.
Okay, I must got something wrong somewhere, but at least we got, wait a minute, back up. We still got 4 minutes. Right here, let's hold this right here. 1 plus or minus the square root of 145 over 6. And we got that right here. Where was it? 145 plus 1. Somebody take the square root of 145. What is it?
12.04159.
What?
12.041.
12.04. Oh,
you
so it's only 12. Okay. I would have thought it was 12.1. So that would be 12 plus 1 is 13 over 6. I still don't get what y'all got. Y'all said y'all got 3? That can't be right because I've got it right here. Square root of 145 plus 1 over 6. Isn't that what I've got here? Ain't that what they got? If that's 6, didn't we say that was 12? 12 plus 1 is 13. 13 over 6 ain't 3.
That's a 5.
What?
That's a 5, not a 6.
What'd you just say the square root of 145 was?
It was 12.04.
Okay, 12 plus 1 is what?
13.
13 divided by 2 is not 3.
I didn't say it was.
I know, but y'all are telling me it was 3.
I didn't,
I thought-
I didn't put a parenthesis for it.
Okay, what'd you get? You should be around 2.
Yeah, 2.173.
Thank you. All right, y'all get out of here. Oh, wait, I gotta wait, let's see, 2 more minutes. I should wait 2 more minutes.
Hey, can you go back to the other page?
It ended at 3:55. Okay, well then I did do like Mr. Gabati, or Dr. Gabati. Y'all want me to do that next time?
No.
Can you go back to the other page?
What?
Can you go back to the other page where you had all your
It was worth every time.
Remember what I told y'all? I told y'all that I treat y'all the way that I want to be treated. Remember that? If people keep acting like jerks in here, I'm going to start acting like a jerk. Hmm?